Okay, in this next short video, we're going to talk about a little bit more about charges and how we charge objects and move towards calculating electric forces. That'll be probably in the next video. So the aims of this video is understanding how electroscopes are devices that we use for measuring and demonstrating charge in objects. Then I'm going to show you a cartoon drawing of how we permanently charge objects by induction, and we're going to see how we can permanently charge objects by conduction. These are two different mechanisms for charging things up. So let's begin. Explain how an electroscope measures charge. The device that you see over here is an electroscope. You would have seen that in grade 10 in the lab. We had it. And what it consists of is a metal plate at the top. Okay, that's our sensor. That's attached to a metal screw that moves down here. And then that screw is attached to two very, very thin and light pieces of gold foil. So I can draw that out for you. These are the gold little pieces of foil that are touching. When I look over here, they're touching. They're not spread out, but I just needed to show you that. So that's gold foil. And I would probably venture to say that that's probably like 1 milligram each one. Very, 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 very light. Okay, and it needs to be light so that it's easy to move. So in the neutral state, those gold foil pieces are actually just gravity's pulling them straight down, like that, all right? And when I bring, let's say, a negatively charged rod to the surface of that, the electrons that are in the metal are going to be repelled, and they're going to be pushing down, and they're going to collect as far away from as possible from that metal rod in the leaves. So these leaves would become negatively charged. Okay, that's if I brought the rod close to that surface. And when they become negatively charged, those two separate leaves are going to swing outwards and repel. Okay, creating a situation that looks like I showed you at the beginning. Okay, they're repelling because they're negatively charged. Now, the more negative charge that I push down there, okay, so the more negative charge that object has, the more electrons it's going to push down into the foil of the electroscope, the further away these pieces of foil are going to move. And what you can see in this device is it has a protractor over there, which would allow me to measure the angle of separation and the amount of separation that these two pieces of foil would move. And for every electroscope, it would say that for every degree, that's how many coulombs of charge is on that rod, because they've calibrated it. If it moved that much, they can say that whatever came in contact with it or close to it is around 10, 20, 30 coulombs. So it's the earliest device that we used to measure charge. And we'll come back to understanding how we can calculate the forces involved in that separation using something called Coulomb's law, if you remember from grade 10. So explain how a metal ball can become positively charged by induction. Remember, that's not by touching objects, that's by just bringing an object close to space. Okay, so if I had a metal ball, okay, I'm going to just change the color here to wood. Okay, I got a wood stick holding on to a metal ball clamped onto a wood surface. Okay, so this is all wood. Why would I mention that that is wood and that the top part is metal? Oops, I don't know why it's not writing. Oh, I selected something. Metal. Okay, the top part is metal, the bottom is wood, because wood is an insulator. Okay, so that's an insulator, doesn't allow the movement of charge, and metal is a conductor. Okay, so if I bring let's make it white. Okay, if I bring a negatively charged piece of plastic towards that metal, okay, but don't touch it, what's going to happen? Well, what's going to happen is the electrons inside that metal are going to be repelled to the other side of the metal. They're going to move and migrate towards that side. So I'm just going to erase all this and draw that again. Okay, so as that rod moves closer, okay, what's going to happen are this the electrons are going to be pushed to this side, leaving the empty protons favoring that side. We've got electrons on that side. Okay. Now the closer that I move that rod to that surface, the more these electrons are going to be pushed to the other side. Now if I would attach a wire to the ground, those electrons will have a good way of escaping that material and getting as far away as possible. So those electrons are going to flow into the ground and get away. All right? So eventually what's going to happen is these electrons that you see over here are going to flow away. All right? And then if I cut, as they flow away, first of all, so I'm losing those electrons. As they flow away, the closer I get, they're starting to flow. These electrons are moving down. And then if I am pretty sneaky and I cut, okay, see scissors, and I cut that red wire. So I'm going to cut that red wire and remove it. Those electrons that were flowing are now stuck in the ground, because that's where they flowed to. This is my ground. Okay, and they have no way of coming back. And then what I can do is take that negative rod and remove it. And what I have left is a permanently charged positive object, this metal object that's attached to an insulator, so electrons cannot go back into it. And now I have a perfectly positively charged object that I can do some fun electricity magic with. All right, and that's called charging by induction. I'm sure you've seen it in your text. Okay, so remember, just to rehash that, you needed a charged object, a negatively charged object that you would move to push electrons through a wire into the ground. Then you would pull that, oh, I'm gonna change that. You would pull that rod back out, but before doing that, you needed to cut that wire so that the electrons would not flow back in, because they would be attracted to those positive charges. And that's called charging by induction. Okay, very useful tool that we can have to cause an object to become positively charged. Okay, now what can we do with that positively charged object? Let's explain how a metal ball can become positively charged by conduction. So let's say that this is a ceiling, okay, the roof, and you have a thread, okay, that's an insulator, all right, and it's attached to a metal ball, okay, a gold metal ball that has a bunch of electrons in it and a bunch of protons in it, okay, and it's neutral. Okay, if I bring that positively charged ball, okay, so let's draw that. So if I bring that positively charged ball in contact, okay, I make it touch the surface, contact. Okay, so what that looks like is if I took this object and I just brought it and I touched, that's contact. Okay, so if I made it touch, then these electrons will move to balance out. So what it would want to do is these electrons would want to move to balance out the charge. Right now, let's say that this is positive 3 coulombs and this is 0 coulombs. If that object, if this object would touch, okay, the electrons inside this circle, okay, that metal sphere, would want to hop over and balance the charge out. Okay, nature wants to balance these charges out. So electrons here would move over, and what would end up happening when I remove them from each other, okay, so I cut the contact, what would end up happening is this object would now be positive 1.5 coulombs, and that object would be positive 1.5 coulombs, okay, because some of those electrons have flown into that object, okay, to balance things out. So we went from positive 3 coulombs and 0 coulombs, okay, we combined that to make positive 1.5 coulombs to positive 1.5 coulombs, okay? And that's when things became equal. Everything wants to drive to become equal. And this is based on the law of conservation of charge. The charges still add up. So this is called conservation of charge. The law of conservation of charge. Okay, so the charge of the objects before contact is equal to the total charge of the objects after contact, and what will happen is that charge wants to become equal. It wants to spread out. Okay, so positive 3 to 0, it spread until they were equal. Okay, so what would happen if I, for example, had a negative 6 coulomb object and I made it touch a positive 3 coulomb object? Okay, what would be the result? How would that charge spread out, okay, onto the two objects after I removed them? So after I removed them, what would be the charge on each of those objects? Well, hopefully that charge would become equal. So what I had was negative 6 coulombs plus 3 coulombs is going to be equal to negative 3 coulombs total. Okay, and that negative 3 coulombs needs to be spread out evenly on those charges. So then what I would have would be negative 1.5 coulombs and negative 1.5 coulombs on each object, because if I add that together, that's going to be equal to negative 3 coulombs, which is the same as the total charge of these objects together. So if I took a negative 6 coulomb object, touched it to a positive 3 coulomb object, the charges are going to combine and spread out and leave that excess negative 3 spread out equally so that I get negative 1.5 coulombs here and negative 1.5 coulombs there.